FVO Solutions Incorporated produces and sells 3 types of hole punches in its facility. The workforce at FVO Solutions is made up of individuals with both mental or physical disabilities. For this reason, manufacturing tasks are challenging to perform. Our team thus chose to improve the fabrication process on one of its 3 models, the 110 2-hole punch model. Through research and design, the team finalized a system of storage devices and tools and reformatted an existing assembly layout for production by FVO employees to fully adhere to the 5S organizational system. The original layout and assembly consisted of a straight 23-foot table with an unused conveyor belt expanding from Station 1 of production through Station 6. For the final layout design, our team discovered that a U-shaped lean cell would be obstructive to an already congested area at FVO. To compensate for this, our team designed a linear assembly line with 5S organization. One-piece flow remained the focus of our team's final 5S design. The first method in 5S is sorting, known as sort. In sort, obstacles and unnecessary items within a production line are eliminated. For sort, the unused conveyor belt from the existing 110 process was removed. The second method in 5S is set in order. Set in order stipulates that all relevant equipment is placed in an accessible manner, ready for immediate retrieval. Here, our team marked with green tape so that each worker could easily determine the next station's demand and start his or her operations in the workflow. For areas with longer distances, such as Station 3, an elevated and angled roller conveyor was also implemented to transport pieces. This reduced strenuous reach of workers and enabled the one-piece flow mechanism of the lean layout. The third method, shine, involves maintaining a clean and orderly workspace. Previous layout for the 110 model did not meet shine standards. This resulted in a slower and possibly unsafe production. To follow shine, our team harnessed part bins at an angle to optimize accessibility. This made the workspace much cleaner. The fourth method in 5S is standardized. Creating rules for the specific work areas, following and enforcing them, is a method by which sort, set in order, and shine are made habitual, which is what standardize entails in our team's case. Standardize was accomplished by first and foremost involving the staff supervisors in the design process. Once supervisors approved and learned the newly improved layout, its order, and 5S organizations, these were taught to FVO employees. The fifth and final method of 5S is sustain, and it seeks to maintain the highest level of order and thus involves regular operation audits. In our team's case, supervisors perform time studies and maintain a constant tally of hole punches produced, as workers at FVO are paid by piece rate. The following table, Table 1, organizes the costs of the new lean implementation. Original time studies were performed by FVO. Our team added the transportation time between stations as shown in Table 2. The time studies for the new lean layout were collected by CSULA team. Table 3 shows the system improvement. The cycle time is defined as the total production time divided by the parts produced during that period. Cycle time of the previous manufacturing system was determined using Equation 1. With lean manufacturing system one-piece flow, the new system's cycle time was calculated to be significantly smaller. The cycle time reduced more than 50% of its original value. This reduction provides flexibility to FVO to meet customers' fluctuating demand quickly. After testing, our team interviewed workers to determine the impact the new changes had on them.
No, that's easier. I could just reach right here instead of just over here.
And it's faster.
And it's faster.
The thin organization, is it good, bad, or the same for you to reach?
It's good. I can work more faster now.
Through designing, testing, and implementing lean manufacturing with 5S methods, it was determined that companies such as FVO Solutions Incorporated, who are made up of workers with disabilities, can not only produce a product efficiency, but thrive and remain a competitive force in the industrial world. Our project completed the following: reduce cycle time, increase productivity, eliminate physical discomfort, stress-free work environment, less defects, and flexibility to meet customers' demand. We would like to thank the following people: